Every surface is defined by its edges. If I erase one of these edges, the surface goes away, and I can recreate it by healing the surface. I'm going to reverse this face. I can subdivide this face into two faces by drawing a line that goes across. It automatically breaks the surface into two pieces. Notice that this inner edge that's on the surface is represented by a thin line, and these outer edges are thicker. These are called profile edges when they're shown in bold. The thickness of the profiles is set in the Style window. You can set it right here. You can even toggle the profiles off so that everything appears thin, but then you won't get that visual distinction between edges on surface and profiles. We can fatten these up if we want to emphasize them, and that might be good for a visual style, but I find that when I'm modeling I want these fairly thin, so I leave the profile set to 2 or 3. You can create an edge on a surface directly by drawing a line from one edge to another, and then we don't have these hanging chads that we have to later erase. You can also draw a line within a surface, but it appears in bold to indicate that it's a profile edge. It's a free-floating edge, not connected to the surface. It's only later, if I decide to connect this profile line to the surface with additional edges, that it will become part of the surface. Now this subdivides the surface into another surface, and I can push and pull that up if I so choose. If I wanted to turn this rectangle into a window frame, I could do it manually by drawing 4 edges and connecting their points, but this is really kind of a tedious way to go, because I have to do a lot of drawing. And I don't have the ability to keep all of these distances the same unless I use guides, and again, there are more steps involved. Now I could push-pull this up and have a frame. A more efficient way to draw a window frame is to use the Offset tool. But before I do that, I'll push-pull this up to create a box. As soon as you select the Offset tool, surfaces start highlighting. I'm not clicking or dragging, I'm just moving the cursor. And this tells you which surface you're going to be offsetting edges onto. I'll click once, and you can see this preview of the edges that I'm offsetting. I'm offsetting the edges that define this surface. If I click again, I set the contours in. Let me undo. You have to be somewhat careful with this tool because there's only a moment there where you have an ability to set the dimension. I'll click, and then look in the measurements toolbar. There's a value given. I'll type in 1 foot and press return. And the lines are immediately dimensioned so that we now have a 1 foot frame going around on this surface. We've subdivided the surface into 2 pieces. I'll double-click on this surface to use the same value. Then I'll push-pull this surface through the box to the other side. And I'll do the same thing here, down to this point. I'll delete this surface. We now have a box with 2 cross members that go across. When I first started using SketchUp, I remember being confused by the Offset tool because I was coming from the perspective of an AutoCAD user. In AutoCAD, the Offset tool is used to duplicate edges a preset distance, and it's used quite frequently in AutoCAD to draft plans. In SketchUp, the Offset tool is something different altogether. Notice that you cannot offset free-floating profile edges like this one. Offset is only used to create interior edges on existing surfaces. If you want a tool that works somewhat like the AutoCAD Offset tool, there's a Ruby script called dline, and it mimics the functionality of the double-line Lisp routine in AutoCAD. You can find it in the Ruby Library Depot.